Here we're going to look at adding fractions and mixed numbers with no regrouping. In this lesson, we're going to look at adding fractions and mixed numbers with no regrouping, both with like denominators and with unlike denominators. Here I'm adding two mixed numbers with like denominators. They have denominators of 3. And then so what we do is we add the fractional part of these mixed numbers first. 1/3 plus 1/3 equals 2/3. And 3 wholes plus 2 wholes equals 5 wholes. Since there's no regrouping within this lesson, this 2/3 here doesn't need to get regrouped. It does, however, this mixed number does need to be simplified if it needs to be simplified. In this case, it does not. Here I have 2 1/5 plus 3 3/10. And in this instance, I do still have two mixed numbers I'm adding. However, the denominators at this point are not the same. So this is adding with unlike denominators. And so what I need to do is I need to find a like denominator. And if you look at the 5 and you compare it with the 10, you're all, oh wait, I know, 5 times 2 equals 10. So we can convert and we can make 2 1/5 into tenths. So we keep the whole portion the same. The 2 stays the same, and we multiply the numerator and denominator by 2 because we want to get to tenths. 1 times 2 is 2. And then the other denominator is already at 10, so we can just write that mixed number there. At this point, now this looks like the previous problem where we had like denominators. Again, what we'll do is we'll go ahead and add the fractional part first. 2/10 plus 3/10 equals 5/10. And we do need to work with those whole numbers as well. 2 plus 3 is 5. Last thing we need to do is we need to simplify 5 5/10. And 5 5/10 is just equal to 5 1/2. Where we simplified that 5/10 into 1/2. And that's my work there for that. Here I'm asked to find a difference of a number because this is a subtraction problem. 7 11/15 minus 2 2/15. The nice thing again is that the denominators in this example are the same. So all we need to do is to go ahead and work with the fractional parts of these mixed numbers first, 11/15 minus 2/15. Keeping that denominator the same. 11 minus 2 is 9. So we have 9/15. We have to put that together with the mixed number, as a mixed number that is. So we look at the whole portions, 7 minus 2, and 7 minus 2 is 5. So we have 5 9/15. What we need to do is we need to write that in simplest form, and to do so, we have to keep those wholes there, don't forget that, and we can divide the numerator and denominator by 3 to get 3/5. 5 9/15 equals 5 3/5. Here I have 7 9/12 minus 3 1/4. Are the denominators the same here? No, they're not. So I'm going to go ahead and find a common denominator. If I listed multiples of 12, I have 12 there. And I know I can go 4, 8, then 12. 12 is a common multiple of those two denominators, so I can just use 12 there. So we got, and we have 7 9/12 minus 3, and how many 12ths? So again, do the same thing in the numerator and denominator. 1 times 3 is 3, 4 times 3 is 12, and I have this equation now to solve. 7 9/12 minus 3 3/12. The answer to that, 9/12 minus 3/12 is 6/12, and 7 minus 3 is 4. 4 6/12, is that in simplest form? Nope, it isn't. If we just divided by 2, because we were, oh, they're both even, we would have ended up with 4 3/6. At that point, we could see, oh, you know what, it's still not in simplest form, and we would have written 4 1/2 as our answer. So 7 9/12 minus 3 1/4 is just equal to 4 1/2. And again, I've shown my work as to how it is that I've made equivalent fractions with that like denominator. Alright, it's time for you to try. We have 9 and 11/16 plus 2 and 1/8. Please hit pause. One of the easier denominators to choose is 16ths, and to get 1/8 to 16ths, we multiply by 2 in the numerator and denominator, and so we have 2 and 2/16, plus 9 and 11/16. 11 plus 2 in the numerators for the 16ths is 13/16, and 9 and 2 is 11. So we have 11 and 13/16, which is in simplest form. 13 is a prime number, and 16 is not divisible by 13. In this case, with 3 and 3/5 minus 1 and 1/4, you might be all, well, what common denominator can I choose? I'm going to give you a hint. Let's choose 20ths. Go ahead and pause the video and solve this problem. I'm going to write in those wholes because the whole portion will stay the same. It's the fractional parts that we had to convert. 1 and 1/4 times 5 was how it is that we would get it to 20ths, times 5 in the numerator and denominator. 1 times 5 is 5. For 3/5, we would have had to multiply by 4 in the numerator and denominator. 3 times 4 is 12. And so our answer, we work with our fractional parts first. 12/20 minus 5/20 is 7/20, and 3 minus 1 is 2. So we have 2 and 7/20. And again, that is in simplest form. 7 is a prime number, and 20 is not divisible by 7. So here's our final problem in our review here. You'll notice that these two here do not have a like denominator. And so what we need to do is we need to get a like denominator for them. Now I could just choose 6, and then what I would do is I would multiply the 1/3 and get 2/6 by 2 in the numerator and 2 in the denominator. However, I'm going to show you that it doesn't really matter as to what you choose as long as you choose and make it the same thing. So for instance, I could end up choosing 18ths as my denominator by multiplying by 6 here and multiplying by 3 here in the numerators and denominators. And so my work here is like this. I would have 6 and 15/18 minus 1 and 6/18. So my goal is always to write those equivalent mixed numbers, or fractions even, so that the denominators are the same. At that point, once I have my denominators the same, I can do my subtraction work, where I work with the fractional parts of those mixed numbers first. 15/18 minus 6/18 is 9/18, and 6 minus 1 is 5. Am I done? Nope. When I'm adding or subtracting fractions or mixed numbers, I always have to work until I get a fraction into simplest form. At this point, 5 and 9/18, I know that 9 and 18 are both divisible by 3. I need to remember to write that whole portion, and then so 5 and 9/18 does equal 5 and 3/6, and if I divide by 3 again, I get 5 and 1/2. Now, if I used the smarter mathematician's way, I would have looked at that original problem and just gone, okay, well, I know it's 6 and 5/6, and I'm writing this vertically, minus 1 and 1/3. 1 and 1/3 is 1 and 2/6, and at that point, 5/6 minus 2/6 is 3/6, 6 minus 1 is 5, and then I would just simplify that to 5 and 1/2 by dividing by 3 and dividing by 3. No matter which way that we approach that problem, though, we still end up with that same answer when we put it into simplest form, because we chose that like denominator and we were very careful to follow the appropriate rules.